Welcome to this video lesson, which is the full solution to the practice questions from the third vector video, which focuses on geometric operations. In this question, we are asked to determine the following vectors in terms of A and B. First of all, vector A originates at O and it goes to L, so that's this vector over here, and vector B originates at L and terminates at M, and that's this vector over here. For the first question, we're asked to determine NO, which originates here and terminates here. We can see that this is pretty much opposite to vector B, which originates from here and terminates here. This is exactly the opposite. It has the same magnitude because, well, we're shown that this side and this side are the same. And since all the sides are actually the same, it means that this is a square and the diagonals also bisect. That means that these sides are also the same. So for NO, which is in the opposite direction of B and it has the same magnitude, since it's completely a negative vector to LM or B, for A, our answer is going to be negative B. Vector NL for part B starts and originates here at N and goes and terminates at L. So we can represent this by starting from here and going in this direction. That's exactly the same as vector A because it is the same magnitude and it's in the same direction as A. So I'm going to start writing that. So for B, it starts at vector A, and so we travel this way, vector A, and then we go in this direction to reach L. So we're going in the opposite direction of B, but we are going, the magnitude is the same as vector B. So we're not adding B, we are actually subtracting B. So this is going to be vector A minus vector B. And I want to show you that also in a diagram over here. If I have vector A, it's going up like this. So that's vector A. And if I were to subtract B, I know that B is going in this direction. So if I were to add it, I would have to attach the tail to the head here, and it would go in this direction. But since I'm subtracting, I'm going to take the negative of this, which is going in the opposite direction here, and add the negative to vector A, meaning put the tail here and change the direction to this direction and add it to here. And my resultant vector goes from here all the way to here. I'm going to redraw it so that I get a nice and straight line. And we can see that this vector over here is the same as this vector over here, which is NL. For part C, we have to write vector PL. So vector PL originates at P and terminates at L. So it's half of the length of NL, the vector here. And usually when we have a vector which is kind of a half length, we're going to try to relate it to some other vector. And in this case, because this side is being bisected by this one over here, that means it's half of the length of NL, so we can write that. So for part C, vector PL is equal to half of vector NL. And we already have found out what vector NL is in the last question, which is really helpful. So I can write this as equals 1/2 of vector A minus vector B. Again, I'm taking that from here. That's the answer here. And that is actually the final answer. I can also write this as 1/2 of vector A minus 1/2 of vector B, And all I'm doing here is I'm using the distributive property 1/2 A and negative 1/2 B. To check our answers, let's kind of draw it out. We know that vector A goes up straight, so half of A is going to go up half of A. So let's say this is approximately half A. And vector B is going in this direction. We're going to take half of it and we're going to subtract it, meaning adding the negative to it. So that's adding half of B, oh, half of negative B really. And when I add them, I get a vector that originates here and terminates here, which is similar to this vector over here. And again, since two vectors are equal when their magnitude is the same and their direction is the same, then half of vector A minus B will be equivalent to vector PL. I hope that this video helps you a little bit with geometric operation of addition, subtraction, and multiplication. Thank you for watching.